Hey everybody, this is Larry. This is me trying to do the virtual contest. It's been a couple of days. I haven't been doing it. My apologies. Oh, secret 10 lead coins. Yeah, I'm still a little bit jet lagged, but I haven't done it in a while, so let's just do it. Yeah. Each prompt will have its own video on explanation and stuff like that. And if you haven't already learned it, then maybe this is, we'll see how it goes. Yeah. And I'm gonna do this live, so let's go. Five, four, three, two, one, go, go, go. Oh, why do you always make me click on an extra thing? All right, well. 2495, let's go. Two lanes less than we go to K. Alright, well. Okay, well. Oh wait, link size 3. Well, yeah. Nice. When it goes to make array equal what? Equal drama? What does that mean? Alright. Choose index. I add the delta to the cost. Change it to x. Okay, maybe. If all element in array. Okay, so basically. Oh. So you basically want to do it to a palindromic number. One that is either the median or as close to the median as possible. Yeah, okay. Yeah, okay, and then okay, so we want to minimize the cost. So that is for a number, so we want to get a number that's closest, so it's the next palindrome and then the last one, right? How do we get the last palindrome number from X? Is it the prefix or the suffix? No, it's going to be the prefix, right? And this is so annoying to do. Alright, fine. There's so many weird edge cases. Okay, fine. I'm thinking for odd and even cases. Okay. So. So then this should be the minimal. Maybe? Oops. Three, four, one. Okay, I mean that's right. Now that's tough to get right. Maybe not. We just brute force a bunch of things. Yeah, okay, fine. So basically, is this as the prefix? Okay, let me think about a case though. We're like 1, 2, 2, 5. 1 to 2, 1 is good, right? Yeah. We have this. Then changing this to 1 is not the smallest one. We want to actually decrement this, right? So we just try a bunch of stuff and hopefully we're right. Okay, yeah, fine. Does that work for strings? I mean, technically this works, but I think for odd numbers that doesn't, or odd digits doesn't make sense. Like if I have, it's going to try like n is equal to 1. Oh, is that not right? Yeah, it's gonna be too much. So yeah. Okay, let's just do the even numbers first. If it is an even digit, then we just do this, and then we try for this number. Yeah. And then we also try something like this. I don't know if I'm going to miss a case. This is going to be very sad. Right. And then else, if this is odd digits, it's going to be the same, but that's still fine. Maybe. Oh man. Isn't quite done yet, but hopefully. I don't know if this is even remotely right. I'm just trying a bunch of numbers. This one is clearly wrong. 121 should be right. But also that's weird though. Why would we not try 121 on this? Oh, odd number. Oh, it's not length of s, it's length of x. No, it's s, but before we divide it into 2. Okay. 6, 11, 22. I mean, that's not quite enough. I want to do something like 1 and 11. What does that give me? 10? Maybe that's right. But what about 1, 2, 11? 10 is that right? Oh, it tries 1, 2, 3. This 2 is the median. I guess that's fine. I was hoping it would go 9. That's why. But yeah, maybe in that range. 1, 2. How would you force a 9? has to be even number of numbers, I guess. $161. I guess any number in between these two are fine. So it becomes like. I don't know if I need this, but I'm gonna try anyway. Still 161, huh? Yeah, because any numbers in between two of them are fine. So the only thing that could be a little bit different is if it is something like that. Then you want to do 999. And the answer is this, but if we don't have it, I guess it's still the right answer. Maybe because of 11111111. I don't know. Why is the answer not 999? Oh, because 1001 is also 1. So you're always close to one of them, maybe. I don't know. Still going to YOLO submit this, I guess. I don't know if this is right. I don't know if I'm missing a case, but that's what Looks okay. Okay. Maybe I could have submitted that earlier. I don't know. That one's kind of hard to prove for me. I think it's just around median. All right, let's focus on this one and we'll chat later. Choose any index I from the array and increase and decrease numbers by I by 1. The score is a final array. Okay, so yeah, you could do k things, and it's the frequency of the most frequent thing. Okay. The English part seems okay. Between the two. Is this I mean, there probably is like a scan line thing, right? K is big though, but no. Does it always have to be the original? Do we always want it, or do the answer always have to be in the original way? I think is what I'm trying to get out. I don't think so. Do you always want the median? Not necessarily. Does it always have to be one of the numbers? The answer may be yes, maybe. Because by definition, if it's not one of the numbers, then you can move it to the left or to the right and still have the same thing, kind of same with the median finding issue. Though I don't know with the K constraint whether that could be done. Can we binary search on each number? Resort, heap. Is there a case where the original number is not I don't think so, but maybe I'm wrong. Because if they're odd, yeah, no, it's basically the same with the median argument. So basically, let's say you have a number, and you want to so is this just sliding windows? In two directions? How do we do the greedy? Because it's in two directions. So every time you add a number, what does that mean? How am I doing on time? I'm an hour 8. Not that bad, surprisingly. I spent so long in Q3 on proofs, but people have gone Q4 though, including Josh. No surprise there, but it's kind of like the median algorithm, but I have to figure out how to do it. It's like sliding window, but median. No, does that work? We did get it pretty quickly though. It feels very median-y, but can we do sliding window on the number of elements? Can we binary search on the number of elements? Binary search, and then you do a linear. How do you do a binary search? Number of elements in the final answer. Do a sliding window. With the rolling median. Keeping track of the median of the number and the thing and the thing. Is that even remotely fast enough? Median is n log n, not a log n, and it's pretty big though. I don't know if you could do that many log n's. So we use 2 heaps. Is this just starting window? Yeah, I guess maybe just starting window. Right. Am I doing the both max heaps for some reason, right? No, we want the min heap from the right. Right, so then now no, that's not right. Okay, so this is sorted, I remember. Let's say you put everything in the middle. If it's a min heap, it doesn't matter. You don't need a min heap. It's an order. Always pop to left, and then what? Cause a moving review. No, this doesn't work. How do you decide whether you want to add a new thing or remove a thing? No, it's pretty straightforward. It's linear. You just do the math. Okay. Yeah, I think I'm a little bit slow on this one. I don't know. I'm struggling a little bit. I don't think this is that bad, but okay, fine. Okay. And then left. Okay, right. I guess I don't know. I don't know why I'm blanking on this one. This is not that bad. Okay, so that's the initial thing. Is this right? Why did I return 3? 1 plus 3, this is wrong. Right? Because you can't connect 1, 2, and 4 by 1. Oh, I'm dumb. So that's 1 and 0 and 2. So 2, okay, so this is the next number, I guess, and it's not inclusive the way that I did it. Okay. And then now, to get the next number, okay, now basically we want to move, we want to do I, and what this means is that okay, delta is equal to numbers of I minus okay, and then all the numbers to the right, so something like y minus I now this is subtracting to the left. I'm like so bad at math today in my head, so that's why I'm printing out everything. Is this right? Kind of. I'm doing it in a weird way, that's why. So the 2, it is still 1. Okay. But then now, we want to see if we want to add so the invariant is that current is less than or equal to k, And then we want to add if, okay, so while current is greater than k, we have to move away from the left. That's for sure, no matter what. So okay, what? That's probably not quite right, but oh wait, this is just really wrong. Whoops. Okay, that looks better, at least for this part not so much, but that's okay. Okay, so because we only remove, so that's probably why. The 2 is going to be 0 and 2, so that's these two numbers, but we actually want to also have the 4, because basically, okay, so let's say we got out. And then now we while we swap, so it's the exchange argument. Well, if we get it for free, then we don't need to. Right? No, it's not this, it's this minus num sub I. What I turned out to be like just really wrong, but people got it so quickly. And this is a textbook problem. I don't know how people do it. 3-3, but I don't think this is. I guess that's fine. Well, the question is, can you swap things in? All right. This minus. Also, this is just wrong. This is this minus num sub I. Oh, the other way around. So definitely just very lucky with these cases. And then I can rewrite this in a little bit better way. Yeah, so if this number is smaller than this number, then yeah, let's roll forward. And technically I want this before. Oh, I keep writing that. Okay. This is going to 0, I guess that's right. 2 and 5. I guess 0, 1, 2, and 5. I guess that's right. Am I right though? I feel like this is not right, to be honest. It feels very I need like. Okay, for 0, this should be 6. Okay, that's true. Now what if we change this to 1? Should be 7. Okay, fine. Where is 2? 8. Okay, fine. I'm gonna submit. I'm not confident about it at all, but I think a wrong answer is worth 5 minutes. Okay, and now we can debug it because I don't know if I could come up with a reasonable answer in 5 minutes and be right about it. Okay, so the answer is 7. Or we expect 8, but my answer is 7. Why is that? I definitely do things in a really weird way. I don't know which way is more optimal. In the swapping, in the greediness. So we swap, but we don't need to swap unless this is the case yet. Okay, maybe that was it. Maybe that, or as we keep on adding things. Okay, fine. Alright, let's give it a YOLO submit. Maybe I should have done that loop thing. I wasn't sure. Ooh. This index. Oh man, how did I do this? Line 12. Yeah, I did it in the wrong order. That was a very beginner mistake. Alright, I'm still not sure this is right. Okay, yeah. but that definitely made it a lot harder to be fun. Is it not greedy? I have 14, the answer should be 15. This is 77. What is the answer? Okay, so for 4, probably less, but okay, 12. 14, 14, 14, so 0 to 12. 77? How did I get 77? At least this is consistent, which is good. Let me do just as a, oh no, it's not that, it's what was this? Minus numbers of I times I minus left, I guess. Well, maybe that's a formula we can use. That's the number of things, right? Oh, I guess it's the difference. Okay, fine. Maybe not. This is just for debugging. Man. But also, honestly, I don't know this one, so it's not like I am making silly mistakes per se. I just don't know. Well, some of them were silly, but it's not just that. Okay, so I just want to verify that this is true. But is either that or the answer is a number that is 14 and between 14 and 20? I don't know. Maybe that is the thing, I don't know. Because I think for these numbers that should be right. Maybe. So this adds 15, that is clearly too much. Fine. I'll write something even more proof for us. Because I want to verify that what I'm thinking is right. I'm lazy. So 4 and 1 is 1, and 12. This seems to match up. So that means to suggest that the answer is in here, maybe. So for example, which is one of my wrong assumptions, I guess. And what are the constraints? Let's just do 30. What? So there's the 15. Is 21, which is not, oh, it is part of the answer. What? Hmm. 21 is 0, 1, 2, 3, 4, 5. Six, 7, 8, 9, 10, 11, 12. Okay, I see. So it's all of these, but I could still squeeze in this one, but somehow it dropped off with 20. Is that true? So 20 went from 3 to 17, and then 20. If And that is a tricky one. Oh, I left in my debugging code. Whoops. Some days. Oh, well, I left in my debugging code anyway, so that would have been failed, but that is most unfortunate still. And I have some printing statements still. So I have 15, but it should be 16. 16 is... I am doing some greedy wrong, am I? Is the input 104? Okay. So we want the answer to be 18, 19, 18. From 1 to 16, so 1, 2, 3, 4, 5, 6, 7. But it has room for 4. Why did we remove the 4? When did this happen? Oh. Because this 15 can only go from 0 to 15. Or whatever it is. And then when the 17 come along, that doesn't make sense, does it? Some British. How much time do I have left? 36 minutes. Oh, so 17 greedily added. Wait, what? What is that total up there? This swapping thing maybe is not, it's nonsense. Do we even need it? Am I just like creating nothing for no reason? I thought I needed it. Yeah, I do needed it for this one. Or something of it. So this is 94. We optimized to go to 93 because this is 13. But I guess we didn't assume that in the future this can go lower. So maybe the sliding window is a little bit wrong. Because for 18, now we can add back the 4. Even for the set. No, yeah. So this one we can. I guess we can always just keep on doing this while, right? I don't know, this just feels like a hack, to be honest. Stuff is already in it, right? So I feel like this just feels sketch. Like there's no way this is right, but I'm just YOLOing. At this point, I have some output, but I don't think it matters. I don't get it though. Like, I mean, I'm glad I didn't do it because I had like 4 wrong answers. That's a really hard one. I don't know if I understand it. I guess that's the problem with greedy problems. Well, I mean, I understand it. It's just more like, is there a way to prove complexity? Well, I mean, as you move from left to right, like I feel like there's a way you can just go back and forth, and maybe that's just like, maybe it's not actually possible. Because the right always goes right, so that's fine. But I cannot prove that left is going to be linear, right? Like, is there a case in which like the input that we had, what if we just keep on adding more numbers? Then it would go back to the right. Would we ever go back to the left? Do we ever yo-yo? So I guess that only happens when we are right heavy. as a result of this, because we still kind of want the median. And because we want the answer to be the median, like all these numbers are the median of the thingies, right? Roughly speaking, I mean, I guess there's some like duplicate stuff, but well, I mean, like I said, there's some edge cases with duplicates, and also like just apart from the edge. Like here, it's just unbalanced because that's literally the entire array. But otherwise, you want everything to be the median. Is that right? I mean, I guess you can do the same thing, but maybe with just like 20 or something. Do you want the median? Well, assuming that this is the middle number, then I guess you don't always need it to be the median, do you? Because you could just be like very heavily on one side. I don't even know if this is right. I mean, this passes the cases, but it may be one of those things that fails afterwards. No, you always want the median, or it may be unbalanced. I mean, it doesn't always have to be the median of the entire array. It has to be the median of that portion. It's going because by definition, if you have the same length and is unbalanced, then you always want the median. And as a result, if you always want the median, because every time you go right, you only go left once. And it's that case, then now you're bounded by linear. Yeah, the optimal answers are always where the median, or where it is the median, right? Because if this has 9 and 7, well, I mean, this is a duplicate case, which is different, but let's say 9 and 6. And just by definition, you make this sum smaller, I mean, even this says a smaller array, so it's a little bit different, but you can make it a little bit more optimal by moving to one side. So the answer is always going to be a median of the local arrays. Like this one, it is 7 and 8. Because even in a very unbalanced side, like even on this one, it's just basically there's a median version, right? Also, I think I off by one of these fit either way. Yeah, okay. I think if you believe in the median thing, which I don't have a strict proof for, then this is linear because by definition a median, for every time you expand this to the right, you can only expand this to the left once. So then this is so it doesn't yo-yo in that way. And then yeah, this is linear time sliding windows, though it's a very hard proof for sure. That's what I think that's what I have for the contest portion. Yeah, let me know what you think. Any shout outs? I'm a little bit late, of course. I mean, I always shout out to Josh numbers. Let's see. People got it very quickly though, so maybe they're less less uncertain as I am. Kind of just go right at it, where I try to prove it too much maybe. All right, that's what I have for this one. That's what I have for this contest. Let me know what you think. Stay good, stay healthy, to your mental health. I'll see y'all later and take care. Bye bye.